The universe is an infinite fractal composed essentially of an infinite number of cosmic explosions known as little Big Bangs. If you consult a science textbook published before 2006, you will see that Pluto was included as one of the 9 planets in our solar system. However, this is no longer the case. Almost 17 years ago, the International Astronomical Union, IAU, redefined Pluto's status and excluded it as a planet. Now, the IAU is again debating this issue because NASA has provided clear images of Pluto, now considered a dwarf planet. Join us on a journey to the far reaches of our solar system to explore the first images of Pluto in our history. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it to reach more people, and turn on the notification bell. We've come a long way since the historic Apollo 11 mission, but the vastness of space poses many unanswered questions. This is where NASA's groundbreaking James Webb Space Telescope project seeks to discover a world of its own. This monumental project builds on NASA's previous missions, and there is great interest in translating special discoveries from prehistory. We are understandably curious to learn more about the Big Bang and how our solar system came to harbor life on one of its planets. The James Webb Telescope, however, has its sights set on the future of our solar system, revolutionizing our understanding. Although it is important to ask whether we need to look back for definitive answers about our universe and perhaps reevaluate them, the Pluto question has been the subject of controversy in the field of space exploration. Thanks to the James Webb Telescope and the discoveries it has provided, we have more and more information to explore our solar system. It seems that the $101 billion investment in NASA has led to a revision of science textbooks to include everything we know about Pluto. This time, it is likely to regain planet status. Here's why. Our knowledge about Pluto doesn't end with the controversial IAU decision in 2006. In fact, it is the new and renewed capabilities of the James Webb that have provided the pictorial evidence needed to strengthen our theoretical understanding of this putative planet. Although previous observations categorized which objects are considered planets and which are not, the IAU had little solid data on which to rely. The rules used for this categorization may have been questionable after the decision in 2006. 2 different scientific positions on the issue emerged. Some believed that the IAU was hasty in declaring Pluto a dwarf planet, while others quickly embraced the new non-planet status. Most space explorers have remained undecided on the matter. However, thanks to the fascinating discoveries of the James Webb, the question of Pluto's status remains. The first sharp images of Pluto provided by NASA are rewriting our understanding of cosmic history. The first and primary human encounter with Pluto was conducted by the New Horizons mission, which has been underway for 17 years. In July 2015, the mission achieved its goal by passing close to Pluto and its many moons. This was the first time humans were able to get a close look at the space relic and collect the most comprehensive data set to date about its moons and surface. The New Horizons mission opened up unprecedented possibilities for NASA in its exploration of the Kuiper Belt, a deep region of space. The main achievement of the mission was the detailed study of Pluto, now considered a dwarf planet, and its largest satellite, Charon. It also managed to capture clear images of the 4 other satellites known as Nix, Hydra, Kerberos, and Styx. Over a period of 15 months, the mission collected data, including the encounter with Pluto and Charon, totaling 6.25 gigabytes. What does this data mean for NASA in relation to the dwarf planet? First, the findings were so groundbreaking that scientists had to develop new data models to better understand Pluto's surface and atmospheric conditions. It was discovered that the dwarf planet was undergoing significant changes in its surface and atmosphere. It was clear that Pluto was far from being a dormant body. It was evolving at a rate that surprised NASA and challenged what was previously believed about this putative planet. The New Horizons mission was groundbreaking, and its encounter with Pluto took place nearly 80 years ago. Since then, the field of space exploration has seen dramatic improvements through technological intervention. With the addition of the James Webb Space Telescope, the possibilities are becoming endless. One might even say that we are getting closer and closer to a complete understanding of our solar system. However, there is an issue with missions like New Horizons and any options to explore planets farther from the Sun. The problem lies in the prioritization of resources, as investing millions to investigate a scientifically important planet may raise questions about the existence of possible life forms elsewhere. Why head to the edges of the solar system? These are challenging questions, to be sure. However, the New Horizons mission marked a turning point in the history of space exploration. Not only did it open new avenues for NASA to invest in the exploration of Pluto, but it also piqued our interest in further exploration beyond the known confines. In the case of Pluto, its study is fundamental to building a broader scientific understanding of other small planets. Although it lies in a cold, dark region of the universe, the first images of its surface proved groundbreaking enough to reveal that Pluto is an active object in our solar system. As they say, a picture is worth 1,000 words, and these crystal-clear images from NASA provide us with valuable information. First, Pluto was found to have a heart. Most geological phenomena on this dwarf planet are driven from its core, scientifically known as Sputnik planum. Surprisingly, it turns out that Pluto literally follows its heart. A quick glance at NASA's high-resolution images revealed that this heart is a white, cold, and nearly frozen left ventricle of Sputnik's heart. It resembles a vast nitrogen glacier spanning millions of square kilometers. Another notable geological feature of Pluto's surface is that the axis of its rotation has undergone significant reorientation, a process scientists call precession. This was unknown to NASA prior to the mission. The dwarf planet's basin is in the opposite position than expected. This reorientation has important implications for understanding the dynamics and evolution of Pluto as a planet. In simple terms, the tidal axis between the moon Charon and Pluto is being influenced by Sputnik planum, the heart of the dwarf planet. This influence has reoriented Pluto so that its basin is more closely aligned with the tidal axis, something that was not previously known. We have always known that this ancient planet is uninhabitable for obvious reasons. However, what was not known is that Pluto's icy surface also causes a tilt due to the imbalance in its mass. The core of the heart of the dwarf planet is a 4 kilometers thick layer of ice, which is very likely contributing to that colossal mass. When combined with tides, this process can cause the reorientation of the planet's rotation axis in search of equilibrium on its own orbit. However, the ice sheet alone is not sufficient to generate a steep reorientation angle or to produce significant heights. As we mentioned before, technologically backed explorations can rewrite our cosmic history, and this is just such a moment. Scientists have also discovered that Pluto is a world with an ocean of its own beneath its thick ice sheets and glacier-covered surface. Pluto's interior contains an extensive ocean that also influences the reorientation of its rotation axis. This discovery is extraordinary for several reasons, but above all because it completely changes our understanding of the planet. The highly probable presence of an ocean in Pluto's crust means that we shall have more information about its origin and how it formed. The discovery of an ocean beneath Pluto's icy surface has ignited new questions and possibilities in planetary science. It challenges our understanding of what constitutes a habitable environment beyond Earth and prompts us to rethink the dynamics of celestial bodies in the distant reaches of our solar system. This ocean, hypothesized to exist based on gravitational data and now strongly supported by the New Horizons mission's findings, represents a potential reservoir of liquid water beneath a frozen exterior. Understanding Pluto's geological processes is crucial to comprehending its evolution over billions of years. The dwarf planet's surface features, including its prominent heart-shaped region and the unexpected reorientation of its rotation axis, provide tantalizing clues. Sputnik planum, the heart's left ventricle, acts as a unique geologic feature. It's believed to be a large basin that may have formed due to a subsurface ocean freezing and causing the surface to collapse, or perhaps due to an impact that excavated material, leaving a deep depression. The New Horizons spacecraft's encounter with Pluto in 2015 revealed a dynamic world far from the cold, inert body it was once assumed to be. The mission captured detailed images of Pluto's diverse terrain, including mountains made of water ice, vast plains of nitrogen ice, and regions with complex patterns resembling cellular networks. These features suggest active geological processes, possibly driven by internal heat sources or interactions between surface materials and Pluto's thin atmosphere. Pluto's atmosphere, although thin compared to Earth's, plays a crucial role in its surface dynamics. It consists mainly of nitrogen with traces of methane and carbon monoxide. During Pluto's elliptical orbit around the Sun, these volatile gases sublimate from its surface, creating temporary atmospheres that vary with seasonal changes. Understanding these atmospheric processes helps scientists reconstruct Pluto's climatic history and its ongoing evolution. The New Horizons mission's discoveries extended beyond Pluto itself to its system of moons. Charon, Pluto's largest moon, displayed an unexpectedly diverse landscape, including a massive chasm deeper than the Grand Canyon and a dark region nicknamed Mordor for its distinctive coloration. Other moons, such as Hydra and Nix, showed irregular shapes and cratered surfaces, indicating a history of impacts and geological activity. NASA's exploration of Pluto and its moons exemplifies humanity's ongoing quest to explore and understand the vastness of our solar system. Each new discovery raises more questions about the origins, evolution, and diversity of celestial bodies, challenging existing theories and prompting scientists to develop new models and hypotheses. Beyond its scientific significance, Pluto holds cultural and symbolic value as a distant frontier that humanity has reached and explored. The images and data returned by New Horizons captivated people around the world, sparking imaginations and renewing interest in space exploration. The mission's success underscored the importance of perseverance and innovation in pushing the boundaries of human knowledge. Looking ahead, NASA's James Webb Space Telescope promises to further revolutionize our understanding of Pluto and other distant objects in the Kuiper Belt. Scheduled to launch in 2022, this next-generation space observatory will peer deeper into space and time than ever before, using its advanced instruments to study the atmospheres, compositions, and dynamics of planetary bodies like never before. The James Webb Telescope's capabilities extend beyond visible light, allowing it to detect infrared radiation emitted by objects in deep space. This capability is crucial for studying cold, dim objects like Pluto, whose faint emissions are difficult to capture with traditional telescopes. By analyzing the infrared signatures of Pluto and its moons, scientists hope to gain insights into their surface compositions, geological activities, and even potential signs of organic molecules. One of the primary goals of the James Webb Telescope is to explore the origins of planetary systems and the conditions that led to the formation of habitable worlds like Earth. By studying objects in the Kuiper Belt, including Pluto and its neighbors, astronomers aim to piece together the puzzle of how small icy bodies interacted and evolved in the early solar system. These findings could provide clues to the prevalence of water and organic compounds in other planetary systems throughout the galaxy. The technological advancements made possible by missions like New Horizons and the James Webb Telescope are paving the way for future exploration of the outer solar system and beyond. Concepts for future missions include orbiters and landers designed to study Pluto's surface in greater detail, collect samples, and even search for signs of microbial life in its subsurface ocean. The search for life beyond Earth is a central theme in planetary science, driving scientists to explore diverse environments and investigate the potential habitability of celestial bodies. While Pluto's surface conditions are harsh and inhospitable to known forms of life, the discovery of liquid water beneath its icy crust raises intriguing possibilities. Similar subsurface oceans may exist on other icy moons in the outer solar system, such as Europa around Jupiter and Enceladus around Saturn. Studying Pluto's subsurface ocean could provide insight into the conditions necessary for life to arise and thrive in extreme environments. By analyzing the chemical composition of water and minerals in the ocean, scientists can assess its potential to support microbial life or preserve evidence of past biological activity. Future missions equipped with advanced robotic technology could drill through the ice to sample the ocean and search for signs of life. The exploration of Pluto and its system of moons also contributes to our understanding of planetary defense against potential asteroid impact objects. Objects in the Kuiper Belt, including Pluto, are remnants of the early solar system and can provide valuable insights into the frequency and nature of collisions that shaped planetary evolution. By studying impact craters and surface features on Pluto and its moons, scientists can reconstruct the history of cosmic collisions and assess the risks posed by near-Earth objects. NASA's planetary defense initiatives aim to identify and track potentially hazardous asteroids and comets that could pose a threat to Earth. By studying the dynamics of the Kuiper Belt and other regions of the solar system, astronomers can improve their ability to predict and mitigate impact hazards. Future missions to Pluto and other Kuiper Belt objects will contribute to these efforts by expanding our knowledge of celestial dynamics and the geological processes that shape planetary surfaces. In addition to scientific research, the exploration of Pluto inspires wonder and curiosity about the universe's mysteries. The images and data returned by space missions capture the imagination of people around the world, fostering a sense of awe and appreciation for the beauty and complexity of our solar system. As humanity continues to explore and expand its understanding of the cosmos, each new discovery brings us closer to unlocking the secrets of our cosmic origins and our place in the universe. The study of Pluto and its moons exemplifies the collaborative nature of space exploration, with scientists, engineers, and researchers from around the world working together to achieve ambitious goals. International partnerships and collaborations enhance our ability to conduct complex missions, share data, and advance scientific knowledge for the benefit of all humankind. By pooling resources and expertise, space agencies can tackle challenges that would be insurmountable for any single nation or organization. Looking forward, future generations of scientists and explorers will build upon the foundation laid by missions like New Horizons and the James Webb Telescope. Advances in technology, including artificial intelligence and autonomous robotics, will enable more sophisticated missions to explore distant worlds and unravel the mysteries of the universe. These missions will continue to push the boundaries of human knowledge and inspire future generations to pursue careers in science, technology, engineering, and mathematics, STEM. In conclusion, the exploration of Pluto has revealed a dynamic and complex world far beyond our previous understanding. From its diverse surface features and subsurface ocean to its unique atmosphere and system of moons, Pluto challenges scientists to rethink planetary processes and explore the potential for life beyond Earth. Future missions, enabled by advances in technology and international collaboration, will continue to expand our knowledge of Pluto and the outer solar system, paving the way for new discoveries and insights into the origins and evolution of planetary systems.